We're moving on with our fractions work today to talk about improper fractions. So our learning targets for today are that you should be able to look at a model, which means a picture, and write an improper fraction for that model. So I can write an improper fraction for a model. Along with that, we'll be talking about mixed numbers, building off of yesterday. Writing improper fractions for mixed numbers. So that's how you'll show your learning at the end, that you can look at a picture and write the correct improper fraction and mixed number that go along with it. So what is an improper fraction? When you look at these three fractions, 4/3, 7/4, and 9/2, what do you notice? Did you happen to notice that all of these numerators are larger than their denominator? So if you think about what that means, 4/3, if you have 4/3, well, isn't 3/3 one whole? So you have more than one whole if you have 4/3. Thinking back to yesterday in mixed number, what that means is you actually have one whole and 1/3 of another. So 7/4, same thing. What would a whole be for fourths? 4/4 equals one whole. So you've got more than a whole or more than one if you have 7/4. And 9/2, oh my goodness, only 2 halves make a whole. So you've got several wholes here. So you have more, or a lot more than one whole here. An improper fraction is a fraction that has a value greater than 1 because that numerator is larger than the denominator. So here's a picture that is trying to illustrate what that is showing as far as what it means. If Mr. Williams has some strips of wire that are each 1/3 meter, we're basically counting by thirds. So here's 1/3, 2/3, 3/3 is one whole. So this is the size of one whole. One whole meaning 1 meter. So 3/3 is one whole. But then if you tack on another third, you have a little bit more than one whole. You've got 1 and another third. 1 and 1/3 as far as a mixed number. So this is showing that 1 and 1/3 is 1, 2, 3/3 plus another third, making 4/3 total. Another way to look at it is a number line. This is also 1 and 1/3. It's showing 1 and 1/3 in particular, but on a number line, if a number line were divided into thirds and we were counting by thirds, we would count 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Once we got to that 3/3 though, we crossed over the one whole. So here we've got 1 on the top, we've got the mixed numbers written. So it's showing the equivalency, that as soon as I get to 3/3, I've got one whole. And then if I kept counting by thirds, I'd have 1 and 1/3, 1 and 2/3. 1 and 3/3 would be 2 wholes. So this is showing the equivalency that if I have 5/3, what that really means is I have 1 whole and 2 more thirds. And once I reach 6/3, I would have 2 wholes. So just a couple different ways to think about what that is saying, what these improper fractions are saying. So, as far as our target, if I write an improper fraction for this model, I'm noticing here with this model that I've got 1 whole and 2/3 of another, so 1 and 2/3. If I think of it strictly in thirds, over here, all 3 of the thirds are blue, and here, 2 of the thirds are blue. And if I put them together, because I've learned how to add like fractions, I add my numerators to give me 5/3. So this model is showing 5/3. 1, 2, 3, 4, 5/3. How about this one? What would the improper fraction be for this model? I've got 1 whole and 1/4 of another shaded in pink. That 1 whole, as far as fourths go, all 4 of the fourths are colored in, plus the 1/4 colored in over here would give me a total of 5/4. So if I've got 1 whole and 1/4 of another, that's showing that I'm adding all of these fourths together to give me 5/4. So the equivalent improper fraction for 1 and 1/4 is 5/4. How about this model? What is this model showing? As an improper fraction, I can see 1, 2, 3, 4, 5. These are all divided into fifths. So all 5 of these fifths are colored in orange. All 5 of these fifths are colored in orange. And then 2 of these fifths are colored in orange. So if I add all these together, 5, 10, 12, I've got 12 fifths total. So there are 12 fifths in these 2 and 2/5. So the improper fraction that is equivalent to 2 and 2/5 is 12/5. What do you have here? What is this mixed number, or maybe it's not a mixed number in this case, and what is the improper fraction that you see here? You can pause, write your answer. Here we have 3 wholes. Each of these is divided into halves, so here I have 2 halves, plus another 2 halves, plus another 2 halves, would give me 6 halves. 1, 2, 3, 4, 5, 6. 6 halves. So 3 is equivalent to 6 halves. How about this one? What's this mixed number and improper fraction? As far as a mixed number, did you say 1 and 3/5? What is it as an improper fraction? Did you get 8/5? So 1 and 3/5 is equivalent to 8/5. Improper fraction, mixed number. Your practice today includes something a little bit new. Well, there is still an IXL. Looking at the IXL records, I know a lot of you really like that form of practice. You get lots of practice problems. So if you like that form of practice, you keep going with that. Today, though, there's also a Quizlet. We, over the past several days, have learned and been using lots of mathematical vocabulary that has to do with fractions. So here is a link. So click on this link to go to a Quizlet that will allow you to just really work with all of these fraction vocabulary words. I want to remind you that when you go there, spend some time up here first, especially with flashcards and learn, so you really get to learn the words. And then I know you love these games, so go ahead and play your heart out with those games after you've spent some time learning the words. And then your must do today to show your understanding of improper fractions along with mixed numbers is to go back to Seesaw and complete the activity there called improper fractions. So well done, third graders. You have learned all kinds of fraction skills. So well done.